Welcome. Today we're going to be going over 1.5. It's literal equations. What are literal equations, and then how can we solve literal equations? So to start off by the definition. Definition means that we have an equation that has at least two or more variables. So I'll go ahead maybe and write that down or highlight it. For sure write it down, but maybe highlight it or box it. And remember that what that definition means for literal equations. So the essential question today is, how do I solve an equation that has more than one variable? So really what we're asking for here is if we have an equation, you're going to try to solve for one variable, and how do we do that? Okay. Down here we have some equations as an example that we have seen in the past. The equation for force. How can we calculate the force of something? Star Wars, the force. Mass times acceleration. So if we know the mass of an object and we know how fast and the acceleration of it, we can dictate the force. So if I know how heavy my fist is, and I know the acceleration from here to an object, I can tell how much force I have. So again, useful formulas and equations that we can calculate mathematically to figure out things that mean real things in our world. How do you find the area of an object? How do you find the volume? So again, if you're going to be doing siding of your home, when you have a home in the future, the roof, we can use math to go ahead and solve some of those problems. Okay. So again, these are just some examples of some formulas that have more than two variables. Okay. So go ahead and write this down. Make sure we're going to do Cornell style. Put the topic to the essential question, and then as you feel free, go ahead and pause and maybe rewind as we go forth. We are on letter A. We're going to go over two examples on how to solve literal equations, and hopefully this will give you some background on how to solve formula equations that have two or more variables. When we have two or more variables up here, we're always going to try to solve for only one variable. And in this case, we're going to solve for t. So if we want to solve for t, we got to look at what kind of math we got to do to go ahead and solve for t. Really what it means is we're isolating the t variable. If we look here, we have three variables. We have three variables. We have d equals r times t. R times t. Remember that whenever you see two letters in a row, that's multiplication. Okay? If we're trying to solve for t, again, we have to look at what's happening to my t variable. I'm multiplying t by something. What is that? In this case, it's r. I'm multiplying by r. So then you ask yourself, what's the inverse of multiplying by r? Well, the inverse of multiplying by r is dividing by r. So what I'm going to do is I'm going to divide by r. Okay? So I'm going to divide by r, and in doing so, I must do to both sides. Okay? The r divided by r is just 1. So I get 1 times t. Okay? You can write down 1 times t equals d divided by r. Okay? But again, 1 times anything is just 1 times anything is just whatever that number is. In this case, it's a variable, so 1 times t is just t. So the answer would be t equals d divided by r. So that's the answer. Okay. Now again, if you're like, how do we get there? What were the steps? Please feel free to go ahead and rewind. But the idea is that we are using the inverse. It's the same principle as chapter 1.1. Okay, 3 sections ago, 4 sections ago. We're just doing the inverse. Down here, we have a different literal equation. This is going to be area. How do we find the area? Area is length times width. How do we find, in this case, the length? When we have this equation here, again, we want to solve for L. What's happening to L? Remember, when you have two letters in a row, it's always going to be multiplication. So we have length times width. So we have length times width. What we're going to do there is we're going to see what's the inverse of multiplying by W. Multiplying by W is dividing by W. Okay? If we divide both sides by W, the W's here, they cancel out, they divide out. You get 1. 1 times L is just going to be L. L equals A divided by W. What's A divided by W? We don't know, so we're just going to leave it like that. Okay? L equals A divided by W. Okay? So again, that's solving literal equations. That's solving equations with two or more variables. And what we're doing is, again, we're looking for what's the variable that needs to be isolated, and we're looking at what's the operation that's happening, and we're going to do the inverse to undo an operation. Okay? Keyword inverse. Okay, we're in part B, so make sure that we're taking our notes, and this is going to be topic B. And we're going to be writing equations in function form. So what does that mean? Well, look here. It means that if we have an equation, we want to have it in the format and the way where we have y by itself. We have y equals the expression, whatever this is. Okay? So that's what function form is. We have in terms of y. We want to get y on one side of the equal sign. So this example here is rewrite in function form, solve for y. Okay. So rewrite in function form, what does that mean? Well, we want to get y by itself. So look, we want to get y by itself. So how do we get y by itself in this scenario here? We got to ask, well, I want to get y by itself by get rid of this 3x. How do I get rid of this 3x? Okay. Ask yourself, what's the inverse of positive 3x? The inverse of positive 3x is negative 3x. Okay? So what I'm going to do is I'm going to subtract by 3x. What I do to one side of the equal sign, I must do to the other side of the equal sign. Okay? That's 0. Positive 3x minus 3x, that's 0. Then I clean it up. What I mean clean up is I bring everything that's still left. I bring down my y. Okay. I have 7 minus 3x. This is where it gets tricky. People sometimes want to subtract the 7 and the 3x. Now, you can't do that because the 7 and the negative 3x, they're different terms. They're not like terms. Meaning that negative 3 has an x attached to it as a variable. Okay? 7 doesn't have a variable. 7 is just an integer. It's a constant. So you can't combine those, okay? Because they're not like terms. So what you do is, well, what do I write down? Well, you write down what's left over, right? Those two terms. We have to write down those two terms. So what you get left over is you get left with 7 minus 3x, okay? That's what you get left over with, right? However, from now on, we're going to practice is that even though this is the correct answer, we want to write it in a way where it looks like this, meaning that we have y by itself. We have that, okay? We do have that. Check. But we want to have it in this order, meaning that the constant needs to go last. The number needs to go last, okay? And what needs to go first after the equal sign needs to be the number with the variable. So what's the number with the variable here? It's a minus 3x. And then what goes next? What I say, what goes last? The number. What's the number? It's 7. Is it a positive 7? It is a positive 7. So when we're doing function form, and again, I would take notes right now. Remember this, when we're doing function form, you want y to be first, y equals, and then you want the same format, where the number goes at the very end, and then the number with the variable goes first on the other side of the equal sign. Okay? So that's the correct answer there. Two more examples and then we'll be done with this video on this section. We have, again, we're still on part B, we're still solving literal equations, In this case, we want to get it in function form. In function form means we got to solve for y, okay? So if we start here, we want to get y by itself. Again, we look at what's happening, how can we get y by itself, how do we isolate for y. What I'm going to do here is I'm going to subtract both sides by 6. These cancel. You get 2y equals 10 minus 6x. Again, you can't combine those because they're not like terms, so then you just leave it the way it is. You leave it negative 6x plus 10. Okay, you leave it like that. What's next? Okay, what's next is you still have y over here. It's by itself on this side of the equal sign, but we have this 2 there. How do we get rid of that 2? You ask yourself, what operation is that? That's multiplication. Right? We're multiplying by 2. So what's the inverse of multiplying by 2? It's divided by 2. Okay? So you divide by 2. What you do to one side of the equal sign, we must do to both sides of the equal sign. Okay? We have to do it to every single term on the other side of the equal sign. So notice that over here we have 2 terms. So we have to take the entire 2 terms and divide both of those by 2. Okay? So we take 2, good. That divides out, we get y equals whatever this is. Okay? This is not simplified yet. This can be reduced. Okay? This turns into negative 6x divided by 2 plus 10 divided by 2. Okay? Fractions. Don't be afraid of fractions. All we're going to do is divide. What's negative 6 divided by 2? Okay? Since I ran out of space here, I'm going to write it over here. Okay, I'm going to put it right here. 6 divided by 2. Okay, negative 6. Well, that's just going to be negative 3. Negative 3x. Okay, the x is still there. Plus, what's 10 divided by 2? 10 divided by 2 is just there we go. And now we have isolated y, and we have y equals negative 3x plus 5. Okay. We're going to do number 3. Kind of same thing here. What I'm going to do here is, since the y is negative, again, you want to get a positive. And I'm going to do the same approach. I want to get y by itself. So what I'm going to do is take this 3x and I'm going to move it over there. I do that by doing the inverse. Okay. This cancels. I get left with my y. Okay. But I'm not going to forget my negative sign. I bring down my negative sign. So negative y equals, what's 12 minus 3x? Again, you can't combine like terms because they're not like terms. So then you bring down, the negative 3x. And then you bring down the 12. Okay, the 12 is positive. So now we have a column to make here. We have a column to make here, and we're almost done. We can say, well, have we solved for y? The answer is no, we have not solved for y. We have solved for negative y. So how do you get rid of the negative symbol? Okay, and this is a trick. We have to divide both sides by a negative 1. Okay? Divide by a negative. Divide by a negative 1. Okay? Now, what I do to one side, I must do the other side. To every single term. If I have 2 terms, I divide the entire thing by negative 1. Okay? And why is this? Well, remember when we divide by a negative, what happens? It turns into a positive. So if we divide a negative by a negative, what's going to happen to my y? Well, it's going to be positive y. Okay? If I divide a negative by a negative, what happens when I divide negative 3 by negative 1? What's 3 divided by 1? It's just 1, right? I'm sorry, just 3. It's just 3. But negative divided by negative is a positive. So we get left with 3x. Okay? A positive divided by a negative is just what?
It's going to be a negative. What's 12 divided by 1? 12.
So that's the answer. Okay. A nifty trick of how to get rid of a negative. If you have y being negative, you want to make it positive. And that goes for anything. So I hope that was helpful. That was solving literal equations. This is, again, make sure to go ahead and rewind, go back, and then if you have any questions, put them on the side, and then I'll see you next time.